Welcome to the second part of the group problems for lecture exam 4. Number 5, in terms of the questions, asks two very simple questions, I think. What are the 3 processes for urine formation? And the other one is the 5 steps in respiration. So the 3 steps in urine formation: you have to have glomerular filtration, tubular reabsorption, and tubular secretion. Filtration is taking plasma and moving it through the glomerular capillaries and becoming ultrafiltrate. This happens exclusively in the glomerulus, which are also known as the glomerular capillaries. As a reminder, we call it ultrafiltrate because it is protein and formed element free. The second thing you need for urine formation is tubular reabsorption. This means that we're going to take important constituents of the ultrafiltrate, which would become urine, and take them back into the body. Things that are reabsorbed would be glucose, water, amino acids, vitamins, and bicarbonate. Most of this, not all, but most of it takes place in the proximal convoluted tubule. The secretion aspect, when we make urine, is when we release waste or other things we no longer want in our bodies into what will eventually become urine through the ultrafiltrate. These are things like acids, creatine, penicillin, and PAH. This happens mostly in the DCT, the distal convoluted tubule. The 5 phases of respiration, I think the best way to remember those are just to think of a stepwise progression from outside to inside in terms of oxygen. How do we get oxygen from the outside air to my tissues to be used in metabolism? So the 5 phases are ventilation, that's number 1. We get exchange of gas between the ambient air and the alveoli. The second one is external respiration, that's exchange of gas with the alveoli and the blood. It's called external because if you open your mouth, the inside of your alveoli are continuous with the atmosphere. The third one is gas transport, moving gas through the system of our body from one place to another, from the alveoli to the tissues for oxygen, and for CO2, the opposite, from the tissues to the alveoli. Number 4 is internal respiration. That's the exchange of gas between blood and tissue. Oxygen goes into the cells, CO2 comes out. And then cellular respiration, where we use oxygen in metabolism to make energy, and in its place produce CO2, carbon dioxide. So question number 5, pretty simple. Question number 6 should be familiar to you all now because it deals with the idea of clearance. And basically, it poses the question, here's a person that's excreting urine at 5 mils per minute. That's high for a urine production rate, I know, but mathematically it just made sense to do that and make the calculations pretty easy for this. We're going to assume the person's going to have a GFR of 125 mils per minute. That's the normal, right? And then we have these 3 different substances that are infused into a person: OF, FNR, and SBF. And then we measure their urine and plasma concentrations and figure out what the clearance of each one of those are. Okay, so clearance is pretty easy to calculate. Clearance, remember, is the amount of plasma cleared of a substance per unit time, right? So it has units of mils per minute. It really measures the kidney's effectiveness of removing substances from the extracellular fluid. Everything is going to have some sort of clearance value if you can find it in blood. Because there's no natural substance that helps us measure GFR, inulin has been created as a synthetic substance, so it's freely filtered, not secreted, not reabsorbed, so that we can use it to measure GFR in a clinical situation. It would have to be infused into someone though, and you'd have to be able to measure the facets of the clearance equation in order to calculate that. If the kidney reabsorbs a substance, the value would be less than GFR, 125 mils per minute. If the person secretes a substance, it would be more than 125 mils per minute. And if the clearance is equal to GFR, it means the substance is filtered, not secreted, not reabsorbed, and theoretically you could use that substance to measure GFR in an individual. All right, so let's look at some of the different things. So to measure clearance, right, you have to remember this formula. The clearance of some unknown substance, substance X, equals the urine concentration of X, what it is in the urine. It doesn't really matter what the units are here because they'll cancel. Times the V, that's the urine production rate. That's in mils per minute. And then the plasma concentration of whatever substance it is. That's also measured in milligrams per ml, so that would be canceled out. So again, for exam purposes, right, this is lecture exam material, you'd have to know this equation, right? And I just remember in my head, clearance equals UV over P. So that's how I remember. So given the information from the table up here, the urine production rate is always going to be 5 mils per minute, and here's the numbers. We're going to take these off the table here and put them into our clearance equation here. And so the clearance of a substance, right, OF from the blood is calculated as this. It was given as 250 times 5 divided by 10, which is 1250 divided by 10. So the clearance of OF is 125 mils per minute. It's filtered because it appears in the urine. It's not secreted, not reabsorbed because its clearance value is equal to GFR, right? And so, not that you knew this, but for me, clearance of OF meant it was only filtered. For the second one, the clearance of FNR, right, we were given 3 milligrams per milliliter in terms of the value, 5 mils per minute, and then 0.5 milligrams per ml for the plasma concentration. Remember, it's UV over P. So we get 3 times 5 is 15, divided by half is 30. So our clearance for FNR is 30 mils per minute, right? So it's meaning it's filtered and reabsorbed. So FNR in my head meant filtered and reabsorbed, right? Since its clearance, 30 is less than 125. The clearance of SBF, right? Given the numbers we got, 150 times 5 is 750 divided by 4, right, is 375 divided by 2 is 187.5 mils per minute. So 187.5 mils per minute is greater than GFR, so that tells us the substance is filtered because it appears in the urine, and because it's greater than 125, it's secreted, right? So SBF meant secreted but filtered for me, so that's where that number came from. So that's the clearance values and how to measure things, and you should be able to interpret those findings as well. We had a bonus number 7. This question asks about Bill. Bill has a disorder. He has large amounts of urine and glucose in his urine, and he asks you about the problem, and he wants to know about diabetes insipidus versus diabetes mellitus. He says he's always peeing a lot, he's always hungry and thirsty, and you need to set him straight. So first of all, right, the first question is, what's diabetes mellitus? What causes it? Things like that. So this is kind of summary of what we've done all semester. Diabetes mellitus, some people call it mellitus, is what people usually think about when they hear the word diabetes. It literally means honey flowing siphon. And basically it refers to the fact that people have uncontrolled urine volumes that have a significant amount of glucose in them. Some Indian tribes in the early Americas would literally, if they thought somebody had diabetes, have them pee on a stick, take the stick and put it next to an anthill, and come back the next day. And if the ants were crawling all over the stick, it meant it had sugar in it, and they knew the person had a problem. They didn't know what it was, they didn't know how to fix it, but they were able to diagnose it. The ancient Greeks also knew about diabetes with sweet tasting urine as well. So a lot of societies had, kind of figured it out, and people that had uncontrolled type 1 diabetes until fairly recently had a life expectancy of less than 50 years because the uncontrolled glucose leads to accelerated cardiovascular disease in most people. So diabetes mellitus is characterized by an inability to control blood sugar levels. The pancreas cannot produce insulin, or we can't respond to insulin. In terms of that, normally the blood glucose is 70 to 99 milligrams per deciliter. If it falls below 70, right, we call that hypoglycemia. If it falls, if it goes above 100, we call that hyperglycemia. And if it gets above 126, that's when the person actually has diabetes mellitus. Type 1 is when you do not make insulin, so there's a damage to or a lesion to the beta cells of the pancreas. Those are the cells that make insulin. It's characterized by glycosuria, that means sugar in the urine. Because we can't use glucose for energy, we have accelerated lipid and protein metabolism. That can cause something called ketoacidosis, where you make these keto acids, which increase the hydrogen ion concentration and decrease pH. You get polyuria, that's because you pee a lot. You get polydipsia, because you're peeing a lot, you're really thirsty. And polyphagia, because your cells are telling you they're starved for energy, so you're always hungry. Type 2 diabetes is when the pancreas makes insulin, but we don't have the response from the cells. This decreases the cellular uptake and again causes similar problems. You also have gestational diabetes, but we're not going to worry about that in this case because Bill's not going to have gestational diabetes because he's a guy. The other disease he's worried about is diabetes insipidus. Diabetes insipidus, which is the reason why it's in this section, is a disease that the subject makes a large amount of water, but it's not a sugar issue. It's because of the ADH. And so the person doesn't make enough antidiuretic hormone, so they pee out a lot more urine. It literally means large amounts of non-tasting urine, diabetes insipidus. So there are a couple reasons like someone might have this. It could be that they have a lesion, a tumor in their hypothalamus or pituitary, so they're not making sufficient amount of ADH. It could be that they also, remember, it's the principal cells that have the receptors. They may not respond to ADH. So if it's the hypothalamus issue, it's called neurogenic. Right, so right here, neurogenic. If it's the ADH is made but not responded by the principal cells, that's called nephrogenic. Remember the nephron, that's where it comes from. So the receptors aren't working. There's also a psychogenic type where people have an ingestion of large amounts of water that causes the same issue. So the major difference between this and diabetes mellitus is the changes in blood sugar. And the blood sugar is the easiest way to measure, or at least urine sugar as well. Significant urine volumes can be over 20 liters a day in ADH because they lack the ability to reabsorb water. Scientific terms for the symptoms that Bill has: polyphagia, excessive eating; polyuria, excessive urine output; polydipsia, excessive thirst. So why does Bill have sugar in his urine? Remember that for reabsorption, some things are reabsorbed through some sort of protein mechanism. In this case, glucose is reabsorbed in the proximal convoluted tubule by proteins. And those proteins, we have a finite number of them, and we've mentioned this all semester. Protein receptors are subject to three things: specificity, competition, and in this case, saturation. And once those protein receptors are saturated, any glucose left in the urine, right, will not be reabsorbed. Okay, so the glucose that's not reabsorbed will spill over into the urine. So this is called transport maximum. And if the transport maximum is exceeded, right, we'll have glucose in the urine. Most people remove glucose from the urine up to blood glucose levels of about 225 to 275 milligrams per deciliter. So as long as your blood glucose stays below those levels, you're not going to have any glucose in your urine. Although it's possible if someone ate a bunch of candy and sugary drinks and things, they could raise their blood sugar fairly quickly, even though they didn't have diabetes, above 300, and they would temporarily have glucose in the urine, but it would go away once their blood sugar went back to normal. If your blood glucose number exceeds the transport maximum, glucose will appear in the urine, and this by far is most common in people with uncontrolled diabetes. So make sure you understand those things, and that kind of summarizes the differences in those. So that is the group problems, and this was considerably shorter than number 1. And you should be ready now, at least partially, for lecture exam 4.